So this is the passage which is based on electromagnetic wave, and what they are asking us to find the relation between E and B and epsilon 0 mu 0. Now when I want to find the relation between E and B, we certainly know that E by B is nothing but speed of light from the theory of electromagnetic wave. Therefore this E will be C into B, and therefore dimension of E will be same as that of dimension of B, and this is LT minus 1. Therefore the correct option for this question is option C. Then they are asking us the relation between epsilon 0 mu 0. Again we know the relation that 1 upon root over of epsilon 0 mu 0 is nothing but speed of light. Therefore if I square, it will be this value. Now I want to find the dimension of mu naught, then I will say mu naught is 1 upon epsilon 0 c square. Therefore the dimension of mu naught will be the dimension of E naught raised to minus 1, and this is c raised to minus 2. Therefore the dimension of mu naught will be the dimension of epsilon 0 minus 1, and the c raised to minus 2 will be L minus 2 t plus 2. Therefore the correct answer option for this is option D. So these two are very simple questions which are simply based on the formulas from the electromagnetic wave chapter. So this is the paragraph which is based on the error part. What is given is R equal to 1 minus A upon 1 plus A, and the error in the measurement of A is delta A. Secondly, this delta is very small as compared to A, and what we have to find is the error in the measurement of R, that is delta R equal to what. So we certainly know that whenever we want to find the error, we differentiate it. So dr by dA, and whenever we are differentiating this, we'll use the division rule U by V. So it will be 1 plus A whole square. This will be 1 plus A, and derivative of 1 minus A will be minus 1, minus derivative of, I will have to keep 1 minus A as it is, and derivative of 1 plus A will be 1. So if I solve it further, what I will get, dr by dA is equal to 1 minus A, and this will be minus 1 minus A, and that will be minus 1 plus A divided by 1 plus A square. Now if I solve this, A minus A will get cancelled out. What I left with, minus 2 upon 1 plus A whole square. As I know that this delta is very small as compared to A, I can write here this as delta A and this as delta R. Therefore delta R is minus 2 times delta A divided by 1 plus A whole square. Now we are going to get the positive error, so I'll just simply take a mod of it, and due to that the answer will be 2 times delta A upon 1 plus A whole square. Therefore the option for this question which is correct is option B. So in this question what is given is the initial number of radioactive nuclei are 3000, and 1000 plus minus 40 are decayed in first 1 second. It has been also given that mod of x is very small as compared to 1, and ln of 1 plus x equal to x for a very small values of it. Now find the error in determination of the decay constant, that is we have to find the delta lambda. Now we know the relation that n equal to n naught e raised to power minus lambda t. Now these are the number of nuclei which are not decayed. I'll simply take a natural log on both the sides. So ln of n equal to ln of L naught, and if I take this it will be minus lambda t. ln E will be equal to 1. Then I'll differentiate this whole term with respect to lambda. Then what I'm going to get, this as 1 by n and dn by d lambda. This is nothing but Now this value is a constant value, ln L naught, so its derivative will be 0, and if I differentiate this, it will be t minus t. Therefore, the d lambda, I can write it as dn upon n into t with a minus sign. Now because this is very small and I want to find the error, so I should write delta lambda. If I take a mod, I'll get a positive error. This will be delta n upon n into t. Now I know that what is the value of delta n. Delta n, it is given as 40, and I certainly know what is n. See, what is given is 1000 nuclei are decayed. So what are the remaining nuclei? Obviously 3000 minus 1000, and this all is taking place in 1 second. If we solve this 0 0, this will be 1 by 50, and finally the answer is going to be 0.02 second. This is the error in the measurement of lambda. Well, here in this expression, I am differentiating this lambda t and I am writing it as t because there is no error in the t. So this is the question which is based on the Searle's method and the concept of vernier caliper. What is given is the diameter of the wire, Young's modulus, length, and the least count is also given. It has been also said that 0 of both the scales coincides with each other, means there is no zero error. The value of G and pi is provided, and it has been said that the load of 1.2 kg is applied. In this case, when we apply this load, what is the reading shown by the vernier scale, or which line of the vernier scale will coincide with the main scale? That is what we have to find. Now we certainly know from the elasticity concept that the formula for this y f by a delta L by L. Now what is going to be the change in length? This is going to be f by a, this y will come here, and this is the length L. Now how much is f? F is 1.2 into g, that is 10. What is the length? That is 1. What is the cross section area? The cross section area is pi d square by 4. And what is the Young's modulus? This is 2 into 10 raised to 11. If you solve this, this 4 will go up and this will become 48 upon pi. We have to take 3.2. This d is nothing but 0.5 into 10 raised to minus 3. This is millimeter to meter conversion, its square. And this is 2 into 10 raised to 11. So if I solve it further, I know that this is going to become what? This is 5 into 10 raised to minus 4, and this 5 into 10 raised to minus 4 its square. So you will get this as 48 into 3.2, 5 into 10 raised to minus 4 its square, so 25 into 10 raised to minus 8, and this is nothing but 2 into 10 raised to 11. If you see it carefully, then this is going to become 25 into 2 is 50. If I multiply 2 on both the sides, this will become 96. This is going to become 3.2. This is going to become 100. This is 10 raised to minus, it will be 10 raised to plus 3. Now 3.2 and 96. Now what is the relation? If I see, this is 3 times 3, 2, 3 this. So it is going to become 30. So 30 upon 100 into 10 raised to plus 3. So if you solve it further, what you will get, this delta L to be equal to 30 upon 100 10 raised to 3. So 0.3 upon 10 raised to 3. This is meter. So if I convert it into millimeter, this is what is going to be delta L. Well, I am intentionally writing this some few calculations in detail. The reason is, in the initial stages, the students may have the problems. Sometimes it may happen that they have the problems in doing the calculations. So this is just going to help them. Delta L is turning out to be 0.3 mm, and I know the least count is 0.1 mm. So which line is going to get coincide? Obviously the third line is going to coincide, and hence the answer will be